Hello, welcome to our channel for probability and statistics. In this video, we will show how to estimate the ratio of two variances. We say if we have two populations which were normally distributed and we want to estimate the population variance ratio, sigma 1 square divided by sigma 2 square. So it's naturally that we can use the sample variance ratio S1 square divided by S2 square, and actually the statistic F, which is the ratio of S1 square by S2 square divided by sigma 1 square and by sigma 2 square. This statistic F has F distribution with degrees of freedom n1 minus 1 and n2 minus 2, where n1, n2 are the sample size for these two samples. So we can write the probability of F between these two F distributions critical value is 1 minus alpha. So for example, alpha is 0.05, so 1 minus alpha is 0.95. So which means if we look at this F density curve, so this shaded area represents the 95% probability. So if 1 minus half alpha V1, V2 represents this critical value. And if half alpha V1, V2 represents this critical value. So the probability of F between these two critical values is 1 minus alpha. So after several steps mathematical manipulations, so we can get the 1 minus alpha confidence interval of the population variance ratio, sigma 1 square divided by sigma 2 square, is 1 minus alpha for the critical value, these two critical value from F distribution times S1 square divided by S2 square. This is the sample variance ratio. So we can have this confidence to say that the ratio of population variance located between these two limits. So we take a look at an example. So say a confidence interval for the difference in the mean phosphorus contents measured in milligram splitter at two stations on James River was constructed, and assuming the normal population variance to be unequal. So the problem is justify this assumption by constructing a 98% confidence interval for sigma 1 square by sigma 2 square, or also for sigma 1 by sigma 2. So we have sample size n1 is 15, n2 is 12, and sample standard deviation S1 3.07 and S2 0.8. So the solution is for 98% confidence interval, which means alpha is 0.02. So after interpolating in the table for F distribution, we find the critical value for F 0.01 with 14 and 11 sample size approximately equal to 4.3. And for the critical value F 0.01 with sample size 11 and 14 is about 3.87. So after we Passing these two critical values in the formula from previous page can get the confidence interval, 98% confidence interval for population variance division is between these two values. So which simplifies to 3.425 and 56.91. And we take square roots of the confidence limits. For this limit, both ends can find a 98% confidence interval for sigma 1 by sigma 2 is between these two limits, 1.85 and 7.55. So since this interval does not allow possibility of sigma 1 by sigma 2 being equal to 1, so we can conclude that sigma 1 and sigma 2 not equal. You can see this ratio does not cover 1. So, which means we have 98% confidence can say that the population variance or population standard deviation are not the same, not equal. Thanks for watching.